Hi all, welcome to Heights to Fly. Today we are discussing about the concept of functions. The concept of functions in relations and functions. In previous class we discussed about what is a relation. Today class we are discussing what is a function. A function associates each element. A function associates each element in its domain with one and only one of its range. With one and only one of its range. We explained these terms. What is a domain? What is codomain? And what is a range? A function associates each element in its domain with one and only one in its range. Consider an example. A is equal to set 1, 2, 3, 4 and B is equal to set A, B, C, D, E. Okay, we are creating a function or defining a function from set A to set B. Here the function, the set A is called a domain and set B is called a codomain, and I am defining the function as set 1 comma B, 2 comma C, 3 comma D, 4 comma E. Okay, I'm defining a function here, a relation here. Then in the domain we take the values 1, 2, 3, 4. Y is equal to B, C, D, E. B, C, D, E. The set is called range. That is the image of x variables made in the function is called range. The image of x variable that is defined in the function is called range. The whole set is called codomain. The image set is called range. Okay. Next we are discussing about what different types of functions. Different types of functions. We can divide functions into 4. One-to-one, second, many-to-one, then on-to, then bijective also. 4 types we can divide functions into one-to-one, many-to-one, on-to-one and bijective. First we can go to one-to-one function. One-to-one functions. What is a one-to-one function? If the images of distinct element of x under f are distinct. Once again, if the images of distinct element of x under f in a function f are distinct. Let's define it with an example. Consider the function 2, 3, 4. This is x and this is y. A, B, C, D, E. Okay. Then here each element of x have a distinct image value. That means one have image A, 2 have image B, 3's image is D, and 4 have image C. So okay, we can define it is a one-to-one relation. Each element of x have a distinct image value or range value. So we can define for FID x1 comma x2 element of x if f of x1 is equal to f of x2, which implies that x1 is equal to x2. If a function is 1 to 1, then for every element of x1 and x2, which is element of x, if f of x1 is equal to f of x2, then we can say that x1 is equal to x2. Otherwise, x1 not equal to x2. Okay. Next, we can define what is many to one relation. What is many to one relation? From the term itself, it is clear that many x variables associates a single variable. That is, if the function is not 1 to 1. Consider the example 1, 2, 3, 4. Here the function can be written as 1a, 1b, 2c, 3e and 4d. Okay, 1a, 1b, 2c, 3e, 4d. Here the variable x have two image values, that is a and b, which is opposite to 1 to 1. Here a single variable x have two image values here, therefore it is many to 1. Many to 1. Then we can define a function like many to many. That means x variables have many x values and x values have y values have many x values. So 1 to 1, many to 1, many to many, such functions are there. Next, onto. Onto functions are also called surjective functions. Surjective functions. And onto functions are also called injective functions. One functions are also called injective functions. Onto functions are also called surjective functions. A function is called onto if every element of y is the image of some element of x under f. That means every element of y is the image of some element of x under f. Okay, that is for every element of y, element of y, there exists an element x in x, f of x is equal to y. Every element of y should participate in that function. Simply saying like that, every element of y should participate or should be included in the function. For example, consider 2, 3, 4. Here the function is 1a, 1b, 3c. Okay. Here all the elements that the y contains values a, b, c. All these are participating in this function or included in this function. So we can say that it is an onto function or surjective function. Simply saying range of f is equal to range of f is equal to capital Y. Then we can say that it is an onto function. If range of f is equal to y, then we can say that it is an onto function. Another example is here we can say that it is an onto function because all the elements in y are included in this function a, b, c, d. 1a, 2b, 3c and 4d. So a, b, c, d are included in this function. Then we can say that it is an onto function. Another case, this is also an one-to-one function also. It is one-to-one function also. 1a, 2b, 3c, 4d. This is one-to-one and onto. One-to-one and onto. Such functions are called bijective functions. Bijective functions. If a function is both one-to-one and onto, then the function is called bijective function. Okay, consider, let's go to some examples, real-time examples. First, let's consider a set of students. Okay, a set of students. Let A be the set of 50 students. Consider A be the set of 50 students. All 50 students in a class. Students in a class. Defining the function set A to the natural numbers. N stands for natural numbers. And the function defined is f of x is equal to roll number of the student x. Roll number of the student x. Then we have to show that the function is one-to-one and onto. Once again the question, consider the function, consider a set A which includes all 50 numbers, 50 students, and the function A tends to n, whereas n is set of natural numbers. F of x is equal to roll number of the students of x. Then we have to show that whether the function is one-to-one and onto. F is a function from A to n. F of x is equal to roll number which is given in the question. Okay, where the student 1, let's take it. Student 1 have roll number 1, student 2 roll number 2, student 3 roll number 3, etc. So each student have a unique roll number. So we can say that the function is one-to-one. The function is one-to-one. The second case, let's go to the second case. The function is defined in natural numbers, that is y is the set of natural numbers. 1 to 50 numbers are assigned to each student. 1 to 50 numbers are assigned to each student. But numbers 51, 52, etc. are pending. That means in the set is y, 1, 2, etc. 50, 51, etc. Only images are from 1 to 50 only. 51, 52, 53, such numbers are vacant. So we can say that the function is not onto. The function is not onto. So we can say that the function is one-to-one and the function is not onto. Let's go to another example. It is a function which is defined from the set of natural numbers to natural numbers, and the function defined is f of x is equal to 2x. We have to show that the function is one-to-one but not onto. The function is 1 to 1 but not onto. Let's take the function f of x is equal to 2x and it is defined from n to n. Okay, natural numbers consist of numbers 1, 2, 3, etc. It's assigning f of 1 is equal to x takes the value 1 and it becomes 2. F of 2 is equal to 4. F of 3 is equal to 6, etc. So we are getting unique values for each x value. So we can say that the function is 1 to 1. The function is 1 to 1. But when we are considering these cases, the set of natural numbers are considering. So they are in range values or in y values 3, 5, 7, etc. are not considering because the function is 2x. 2x, x can take only values from 1, 2, 3, etc. So f of x not containing values 3, 5, 7, etc. because f of x is equal to 2x. Hence we can say that the function is not onto. The function is not onto. Let's go to another example. Consider a function which are defined in from real numbers. Function f defined from real numbers to real numbers. F of x is equal to 2x. Here R is set of real numbers. So x can take any value, positive value, negative value, rational value or anything. So take any value and this. So f of y or f of x can also get any value. That is, we are assigning 0 to 1, it will get 0.2, 0.05, it will get 0.1, like that. So we can say that is a 1-to-1 function and onto also. 1-to-1 function and onto also. See the case, the function is f of x is equal to 2x. In the previous case also the same, f of x is equal to 2x, but the defined set of numbers. In previous case it was natural numbers, here the set of real numbers. Same function, two set of numbers, that was answer is different. In previous case the set was not onto, here the set is onto. So consider this always the limit of values. Okay, so today class we defined what is a function and what are the different types of functions. And in types of functions we defined 1-to-1, many-to-1, onto, bijective, etc. And let's discuss about some examples also. Okay. Last case we discussed, that is a function from real numbers to real numbers. F of x is equal to 2x. Here the function is 1-to-1, not onto. So we can say it as bijective function. We can say it as a bijective function. Okay. On next class we will discuss more about relations and functions. So thank you for watching. Subscribe and share for new videos.